Hi everyone, today we're talking more about rate of change. So before we talked about how the rate of change tells us how fast your line is increasing or decreasing. Remember that we use linear functions to describe or approximate relationships in the real world, and that's called linear modeling. A lot of times, mathematicians or scientists will actually choose to make a linear model because it's just easier for them to visualize what's going on, to look at a line. And using a linear model, you can follow y equals mx plus b to show the slope m, which is the rate at which you're increasing or decreasing. And then b is the initial value, so your starting point. So very important, if you don't have this in your notebook yet, y equals mx plus b. M is the slope that's telling you the rate at which you're changing. And then your b is the initial value, so your starting point. And today we're going to look at a couple of examples so that it makes a little bit more sense for us and we get some practice. This is example 2 from your book. It says that the table below shows the distance y kilometers traveled while driving on a highway. So in your table, you have your time, which is x hours, and your distance in y kilometers. So this means that after 1 hour, you will have gone 90 kilometers. After 2 hours, 180 kilometers. After 3 hours, 270, and so on. And this looks like it's a constant rate of change. It looks like you're adding 90 for each hour. Every time I add an additional hour, I am adding on 90 kilometers. So that's a constant rate of change. Now notice how from 3 to 3.5, I'm adding on a half hour. So then you would assume that this difference would be half of the normal difference within an hour. Half of 90 is 45. So let's check. Is 270 plus 45, does that equal 315? Yes. Okay, so that's why that's a little off, because it is going by a half jump instead of one complete jump, but it's still the same change. All right, so back to the task. This problem wants us to first draw the graph of y against x for just the values of x equal to or greater than 0, and then equal to or less than 3.5. So this is why our graph only shows quadrant 1. We don't really care about the negative values because your car really isn't going negative distance or negative hours. So we're just focusing on this quadrant here with our positive values. Once we draw that graph, they want us to find the slope of the graph and explain what that slope represents, and then find the initial value, and lastly, express your relationship as a function. So let's start off with our graph. I need just the values of x between 0 and 3.5. So let me go ahead and label by going by ones, 2, 3, 4, and 5. And again, this right here represents our time in hours. And then going up and down our y-axis, they're telling us that that's our distance. So I always want to label my graph so I know what's going on. This is my distance in kilometers. And that's going up, we said, gradually by 90. So let's make sure that each jump is equal. It's going up by 90, 270, then 360, because it's basically multiples of 9, then 360, because 4 times 9 is 36, 5 times 9 is 45, 450. All right, and then we just need a graph. So this is 1 and 90 2, and 180, and so on. So 1 and 90, I have a dot right there. 2 and 180, dot right here. 3 and 270, dot right there. We said, oh, the next one's 3.5, so that's between 3 and 4 and 315, which is also halfway there. All right, and then our graph needs to have a line going through all the points. And then an arrow showing that it goes on forever. If this car were to go on forever, don't need an arrow this way because your car's not going to travel a negative amount of hours. Okay, so that's A. And now next we have to find the slope. So let's go ahead and do that. Slope means that you had to find 2 points and then figure out their rise over run. So here's a point. And then here's a point. Let's use these 2 points. This rise and run. Let me draw that a little bit better. Okay, so my rise, it's starting at 180 and going up to 270. So it's going up 90 and now going from 2 to 3, so adding 1. So my rise over run is 90 over 1 or 90. That's my slope. What does the slope represent? Well, my 90 is my change in kilometers, and then my 1 is my change in hours. So it looks like it's 90 kilometers per 1 hour. So really the slope is the speed of the car. And remember, I found the kilometers by saying, okay, this was plus 90 for my distance, kilometers, and this was plus 1 in my time scale, which was in hours. So that's how I got that it represented actually 90 kilometers per 1 hour. All right, now let's focus on C. C is asking us to find the initial value of y. Okay, initial value in the beginning is 0. So b equals 0. What does that mean? It means that before we even start recording this distance of this car or vehicle, it had traveled 0 kilometers. It just started at the starting line. It hadn't traveled any distance. Okay? Which makes sense. Okay, now D, express y as a function of x. All right, so if we need to write it as an equation, it needs to follow y equals mx plus b. We have all that information. Let's just plug that in. Y equals the slope, 90, times x, plus b. We don't have a b. It was 0. So we can leave it like this. Y equals 90x. And then that will show you the relationship of x and y. Okay, let's move on to example 3. Example 3 says that Knox had some gasoline in his truck. After driving 100 miles, he had 11 gallons left. After driving 100 miles, he had 11 gallons left. So it looks like each 2 units is equal to 1 gallon. Okay, so that's good to know that this is actually 11, 2 units up, because it lines up with what they're talking about in the problem, which says that after 100 miles, he has 11 gallons left. The graph below shows part of Knox's journey. All right, what do they want us to do? They want us to first find the rate of change of this linear relationship. Rate of change means slope, so we just have to find rise over run. And then we have to explain what that rate represents. Remember, we can use that scale to figure that out. And then they want to figure out the miles per gallon, MPG, of Knox's truck. Part C asks us what is the meaning of the value 15 on the vertical axis. And then part D wants to know, assuming the rate that you found remains constant, they want to know what's the maximum distance Knox can travel before he runs out of gasoline. Okay, go ahead and pause this video and try it on your own first. Okay, let's take a look. We first have to find the rate of change in this linear relationship. Well, rate of change, slope, basically requires us to find 2 points and figure out rise over run. We already figured out that this was 11, and let's do it. Let's use rise over run by drawing our triangle. Okay, so this rise, starting from 11, moving up to 15 is plus 4, because 11 plus 4 is 15. This is plus 4 on the gallons scale, right? Because going up and down tells us the gas in the tank in gallons. Okay, now we're here. We need to move backwards from 100 back to, looks like 0. So then that's minus 100 because you're going backwards, 100 back to 0. Okay, so then it looks like our slope is 4 over negative 100. That's our slope. Well, let's go ahead and reduce that because slope needs to be reduced. Divide both sides by 4. So you end up with 1 over negative 25. That's our slope. Slope is negative 1 over 25. But what does that mean, right? Remember, our rise was our gallons. And then our run, we didn't write that down, is a run is going across our x-axis, which is miles. So it's 1 gallon per 25 miles, and it's negative. Okay, so that negative tells us something important. So that means the negative means that we're using up or losing gas. Okay, so basically the slope, this rate, tells us that we use up 1 gallon of gas for every 25 miles driven. Okay, because it's going downwards, it's decreasing. That's why it's negative, using up. If it were positive 1 over 25, then it would be like gaining gallons of gas, but obviously that doesn't make sense in this problem. Okay, so rate of change, negative 1 over 25. And since it's negative, it means that we use up 1 gallon of gas for every 25 miles driven. Okay, part B. What is the MPG of Knox's truck? Well, we already found out that it was negative 1 over 25. The negative 1 was for the gallons of gas, and the 25 was the miles from part A, right? So now they want to find the miles per gallon. Okay, the slope we found, the rate of change, was gallons per miles. They want miles per gallon. So it's basically switched around. So that's all we're going to do here. Miles per gallon will just be, instead of negative 1 over 25, it's 25 over 1 because we want miles per gallon. Miles on top, gallons on the bottom. So this answer is 25 miles per gallon. That's the MPG of Knox's truck. Every car has an MPG. You can look up your family's, every car, not just truck. Every type of vehicle has an MPG. It tells you how far that car can go using each gallon of gas. And Knox is driving a truck, so his MPG is going to be lower than, say, a compact car because trucks are heavier. So this 25 actually makes sense. A lot of smaller cars, since they're lighter, they can go faster, or they can go for a longer distance actually with less gas. So for instance, my car, which is a smaller car, has about like a 33 miles per gallon. But then obviously it can't handle a lot of heavy things because it's a smaller car. Okay, so that's all MPG means. All right, now they want to know, what is the meaning of the value 15 on the vertical axis, this right here? That's our B value, but they want to know, so what is 15, right? Now let's go back and read the problem. Knox had some gasoline in his truck. After driving 100 miles, he had 11 gallons left. So what do you think 15 would mean? Well, 15, since it's the starting point, it would just mean that Knox started off with 15 gallons of gas. That was his starting point for gas. That's all that means, because it's the starting point, the B value. Okay? And then the last problem asks you, assuming the rate that you found in part B remains constant throughout Knox's journey, that was the 25 miles per gallon, what would be the maximum distance Knox can travel before he runs out of gas? Okay, so 25, my bad, 25 miles per gallon was Knox's truck's capacity, okay? And they want to know basically how far can Knox go with 15 gallons of gas before he runs out. Well, what we could do is we could extend this graph, but hello, that would go beyond the paper, right? So now we got to think to ourselves, okay, if it's 15 gallons that he has in his truck and each gallon can get you 25 miles, then really all we have to do is take our 15 gallons, right? And then we have to multiply it by 25 because each gallon gets you 25 miles. And so let's put that in our calculator. 15 times 25, 375. 375 miles. So if Knox were to use up all that gas, then he can go a total of 375 miles because each gallon gets you an extra 25 miles. And that's it. All right, so to summarize everything that we've learned so far, you can add this into your notebook. So we so far just talked about a straight line. The slope of a straight line should be the same throughout the line for all its points, right? So your rise over run is the same no matter what 2 points that you choose. And a linear function, a straight line, should have a constant rate of increase or decrease because it's either going up, up, up for an increase or it's going down, down, down the entire way. But it's not going to change. It's constant. We call it increasing when y is increasing the same as x, or y is decreasing when x is decreasing. And that's going to be a positive slope. A negative slope is going to create a decreasing graph. Okay? And then when you have a slope that is 0, that's when, the function is neither increasing nor decreasing, but it's also constant. So a straight line is going to give you always a constant rate of change. In our next lesson, we will talk about when we don't have a constant rate of change, but just know when you have a straight line, it's either increasing, x and y are both increasing together, and then decreasing means one's going up and one's going down. Kind of like the gas problem that we just did, right? Your distance is going up, your car is going further and further, but your gas is going down. They're going in opposites direction. Okay, so x and y change together for your increase. And then for decrease, x and y are opposites.